Last class, we learned how to find all the rational roots of a polynomial using synthetic division and factoring. What if we can't factor as our last step to find the remaining zeros? We can find the remaining zeros using the quadratic formula, or complete the square. So if we want to find all the zeros of this polynomial, the first thing we need to do is look at the graph. So we're going to go to our calculator, or you can use desmos.com/calculator. Go to y equals, and put in our equation. So x cubed minus 5x squared minus 7x plus 51. And we're going to graph it. Now, we know from our exponent that we're going to have 3 solutions. Since the graph only crosses the x-axis once, we have one real solution and the other 2 are imaginary. We know that our real solution looks like it's at -3, and we can use the table to help us check. Second graph, we look in the table at -3, y equals 0. So we know -3 is going to be outside our synthetic division. Then we're going to bring down our coefficients. Bring down the 1, multiply, add, multiply, add, multiply, add, and we get a remainder of 0, just like we should. So if we put our x's back in, we know x squared minus 8x plus 17 equals 0. We can't factor this. The only factors of 17 are 17 and 1, and that won't add up to -8. So we're going to use the quadratic formula. We're going to start by finding our discriminant, so b squared minus 4ac gives us -4. Then we're going to plug into our quadratic formula, so x equals -b will become +8 plus or minus the square root of our discriminant all over 2 times a. If we simplify this, we get 8 plus or minus 2i over 2. And since both of these terms are divisible by 2, we're going to simplify it a little bit more. So x equals 4 plus or minus I, which gives us 2 of our solutions, 4 plus I and 4 minus I. And then our third solution is the -3 from our synthetic division. So now let's try one, and we're going to use the use completing the square to solve it. So again, our first step is to look at the graph. So I'm going to go back to y equals. So x squared minus x cubed minus 6x squared this time, plus 9x minus 2. And graph it. So this one's a little harder to see where it crosses. It does cross 3 times, so all of our roots are going to be real. If we go to our table to help us see where the y value is 0. So we're going to use 2 is our rational root. That's going to go outside our synthetic division. bring down the 1. 1 times 2 is 2. Add, we get -4. Multiply, we get -8. Add, we get 1. Multiply, we get 2. And we get a remainder of 0. So we have x squared minus 4x plus 1 equals 0. If we want to complete the square, that means we're going to have to move the 1 to the other side. Find our numbers in the blank. We're going to do b over 2 squared, which gives us 4. We're going to factor this side and simplify this side. Square root both sides. We get x minus 2 equals plus or minus the square root of 3. And then move the 2 over. So x equals 2 plus or minus the square root of 3. And our other solution is the 2 from our synthetic division. If you notice in both of these, in front of our as part of our irrational root, we had a plus or minus. And as part of our complex root, we had a plus or minus, which helps us with the complex conjugates theorem and the irrational conjugates theorem. If you remember conjugates from back when we learned complex numbers, conjugate just means the sign in the middle changes. So we know if a plus bi is a 0 of our polynomial, then we know that a minus bi will also be a 0 of that polynomial. Similarly, if a plus the square root of b is a 0, a minus the square root of b is also a 0. So based on these zeros, we're going to determine the others. 3 is just a rational number. It doesn't fall into either of these categories, so we're not going to know of another root just because of that one. 2 plus the square root of 5 is an irrational number. We know if we have a plus the square root of b, we also have a minus the square root of b. So we know that 2 minus the square root of 5 is also a root. And number 4, both of these are complex numbers, so they both fall under the complex conjugate theorem. So we know that -5i is a root, or 0, and 3 plus 4i is also a root. Take a second and try the last one. You should have gotten that 7 minus 2i is a root, and 1 plus 3 square roots of 2 is also a root. And we need these theorems to help us when we go backwards. So we already know how to write a polynomial function if given the rational zeros of a function. To find the factors for the irrational and complex zeros, we will use a process called uncomplete the square. So when writing these polynomials, 4 is our rational root. We're just going to leave it alone for right now, and we're going to come back to it later. If we have 1 plus the square root of 5 and 1 minus the square root of 5, we could rewrite that as x equals 1 plus or minus the square root of 5, which is an answer that might occur when we've completed the square. So we're going to use that process to go backwards. So let's look back at our second example. What was the last thing we did here? The last thing we did was move the minus 2 that was over here, and we added it to the other side. So what we're going to do is we're going to bring it back. So we're going to take the 1 and we're going to subtract it to the other side. So we have x minus 1 equals plus or minus the square root of 5. Let's see what the step before that was. The step before that, we square rooted both sides. So if we're going in reverse, the opposite of square rooting is to square. So we're going to square both sides. Now, this is very important. When you square something like that, it means to multiply it out. So we get x squared minus x, so minus 2x. Negative 1 times negative 1 is plus 1. If we square the square root of 5, or we square the negative square root of 5, we're going to get the same answer. So if you square a square root, they undo each other, and we're just left with the 5 that's underneath. The last step is to bring this back so it's equal to 0. And I have x squared minus 2x minus 4 equals 0. Then we need to take that polynomial and multiply it with the factor that we would have if we have a root of 4. If our root is 4, we know our factor is x minus 4. And now we're going to multiply this all out. X times x squared is x cubed. X times negative 2x is negative 2x squared. X times negative 4 is negative 4x. Now negative 4 times all of our second set of terms. Negative 4 times x squared is negative 4x squared. Negative 4 times negative 2x, positive 8x. And negative 4 times negative 4 is plus 16. So when we combine all of our like terms, we get that f of x equals x cubed minus 6x squared plus 4x plus 16. Let's try one more example like this. So here we know that 2i is a root. If 2i is a root, we know that negative 2i is also a root, so we know that x equals plus or minus 2i. And we know that x equals, if x equals 3 minus the square root of 3, we also know that 3 plus the square root of 3 is a root, so x equals 3 plus or minus the square root of 3. So we're going to uncomplete the square with both of these, and then we'll have to multiply the results together. In our first one, there's nothing in front of the plus or minus to move to the other side, so we can square both sides right away. We get x squared equals 2 squared is 4, I squared is negative 1, so 2i squared is negative 4. Also, what you could do on your calculator, you could do parentheses 2i squared. Just make sure the 2 i's in parentheses and the squared's outside. We get negative 4. Then we have to make it equal to 0, so x squared plus 4 equals 0. And we're done with that part. So let's move over to our second set of solutions. This time we do have something in front of the plus or minus, so we're going to move the 3. Then we have to square both sides to get rid of the square root. When we FOIL this out, we'll get x squared minus 6x plus 9. The square root of 3 squared is 3. Move the 3 to the other side. We get x squared minus 6x plus 6 equals 0. Now we need to multiply that with our answer from our first uncomplete the square. So we get x squared times x squared is x to the 4th. X squared times negative 6x is negative 6x cubed. X squared times 6x is plus 6x squared. 4 times x squared, 4x squared. 4 times negative 6x, negative 24x. And 4 times 6 is plus 24. And if we combine all our like terms, we get x to the 4th minus 6x cubed plus 10x squared minus 24x plus 24. One way to help check your answers to these is to use our poly root finder. So if we go to apps, polysymult, choose our root finder, we ended up with an x to the 4th polynomial. Go to the next screen, put in our coefficients, so 1, negative 6, 10, negative 24, and positive 24. And if we solve it, we should get plus or minus 2i and 3 minus the square root of 3, plus or minus. So this part at the beginning of these with the 2 i's on the end, it means negative 7.5 times 10 to the negative 14, which is basically 0. The calculator just doesn't handle it well. So we have our plus or minus 2i, and these irrational numbers are ones that are 3 plus the square root of 3 and 3 minus the square root of 3. You can also use your app to check your answers to the ones at the beginning to make sure that 2 plus the square root of 3 and 2 are the solutions to this. That's all for today.